I'm Carlos Mendizabal, Senior Software Engineer at Snowflake. I have been at Snowflake for about 2.5 years, and I am in the metrics team, observability metrics at Snowflake. Now, in these 2.5 years, we've worked on a lot of things, but one of the most important projects we've had is migrating from our previous software as a service metrics vendor to a Prometheus-based solution. So in this talk, I will talk about what this took, and in particular, the process to migrate the dashboards and alerts to, again, this Prometheus-based alternative. So with that, here's just some disclaimers that my friends at Legal asked me to share, so aware they're there. And let's talk of some background. Metrics at scale. What is the scale that Snowflake is running in? First, let's think about where Snowflake runs. It's global and multi-cloud. It runs on all 3 major clouds and regions around the world. Snowflake has over 200,000 VMs hosting its distributed infrastructure, again, across all these clouds. And not only that, but Snowflake also hosts infrastructure in different types, or hosts itself in different types of infrastructure or its applications. In particular, at the time of the migration, these stats are from from when their migration began, just at the beginning of this year. We had 190 Kubernetes clusters where we replicate our metrics collection infrastructure. And then additionally, to add just some complexity to all this, there are governance zones, different governance zones that we operate in. Think sovereign clouds, different countries, different regulatory environments, some are siloed, etc. Different infrastructure that cannot, run in every single country and so on. So we have to work with these constraints, and as the metrics team, we still have to collect and process and then show metrics from all of these environments. So now let's think more specifically, what is the scale of metrics at Snowflake, or the monitoring needs at Snowflake, again, particularly at the time of the beginning of this migration, at the beginning of this year. Now, before I do this, I do want to make sure we're all on the same page. What is a metric? I'm sure a lot of people here are probably more than familiar with this, but to make sure. A metric, again, we have a set of data points. These are various points in time. So in every particular point, you've got label value combinations, and then one of those labels, usually a metric name, and over time you have every unique combination of label of key value pairs for labels gives you a time series. So in this case, our first stat, we had 2 million points per second sent to our software as a service metric provider at the start of the migration. Again, these are 2 million unique points, but it doesn't tell you so much about unique time series. We were not measuring things in, for example, active time series at the moment, but I know it is a commonly used stat, and we do now. For those that are aware of it, currently we have 400 million active time series. So this specifically means time series in memory over the last 2 hours, different time series in memory over the last 2 hours. And again, I emphasize, every unique combination of label value or of labels gives you a new time series. So this is the cardinality that we're talking about. What kind of growth are we experiencing, or were we experiencing at the moment? Well, 60% allow listed metrics growth at the time of the migration. Why do I call out allow listed? Well, teams at Snowflake, anyone can set up a service or an application or whatever they want, and then, send metrics our way, or set things up so that the metrics get scraped and sent to our pipeline or aggregation infrastructure. As it turns out, metric systems, as we will talk, first of all, scaling them can be a challenge, and they're expensive. So we need some gateways to allow us to control what is actually going to the real-time metrics backend. That is the allow list. But I call this out because these 60% growth is metrics that are very much intentional. These are metrics that our engineers have declared they need added, and then we're ingesting into our real-time metrics backend, or in this case, the software as a service provider we had before. And then at the beginning of the migration, 70 teams, well, just over 70 teams that each maintain their own alerts and dashboards. And again, some context, an alert and dashboard. What is it about? You probably know, but if you don't, the alert, pretty simple. It's what you're actually, telling you when something is broken based on some condition, the metric. The dashboard, it's a pre-created view of something important that you want to track. Maybe you want to track a release or a system overview, etc. You probably will look at a dashboard after an alert fires. So let's talk about just some context. What made us migrate? What were the motivations to go there in the first place? The scaling limitations that we were experiencing. First, reliability. So I have mentioned 2 million points per second is what we were sending. And at that point, well, we were struggling. Relatively frequent incidents or more than, we wanted. And importantly, again, software as a service solution, no direct control over it. Now I have to emphasize here, alerts, dashboards, you probably know this, but they're critical infrastructure. Your system, your company is relying on them. Obviously, you have whatever availability guarantees that you're putting out there, but if your metrics infrastructure is not running, you really don't know if you're meeting them. For all you know, you could be down. So really, you should treat your metric system to be as reliable as you're promising your underlying website, system, application, etc. Should be. Scalability limits. So I just mentioned 60% year-over-year growth rate. But if we're already hitting limits at that scale, then clearly we don't have room for growth. And here's when I reveal, I lied a little bit when I said 2 million points per second. I didn't lie that wasn't where we were at. I just didn't mention we actually had been there for some time. So we were at a point where we were just mitigating how much we're sending to the metric system because we know we really can't take much more. So looking at metric usage, there's usually a lot of metrics that maybe you can clean up. So a lot of effort in that area, but there's only so much that you can trim before you're really cutting into critical metrics that are used to, again, monitor your system. Now, I want to mention this other part, and I will talk about this more in detail, but alert scale. We had 100,000 different alert rules running, evaluating alerts, in theory, or supposedly every minute. Now, this is not just the metrics backend that we're using, also some poor decisions that we made many years ago. I'll talk about them more in detail. But importantly, at that scale, we're at the point where the alerting system is not keeping up. Again, I mentioned, the alerts should be running once a minute. You basically evaluate your condition, and over time, maybe you want to alert after 10 minutes or whatever, you fire your alert. If this evaluation is lagging, well, you get the point. You might not find out until much later. We actually had an alert that's supposed to be always firing and letting us know, to validate that things are working. And this, again, fires every minute. We often found, or not often, but more than it should have, it firing, because of more than 15 minutes of no evaluation. More frequently, maybe 4 or 5 minutes. Cost. Our friends in finance reminded us often just how expensive metric systems can be, especially expensive when, well, you don't really control how much it costs to begin with. You've got contracts with a third-party service provider, etc. And we were hitting a lot of limits there too, and a lot of pressure to mitigate our cost. So we needed to find more cost-efficient alternatives. With that in mind, let's backtrack a little bit and let's try and understand what was the context when this previous system was set up in place, and again, the previous decisions. Again, Snowflake, smaller company. I wouldn't say it was a small company, 5, 6 years ago or so, but it was smaller. A smaller number of teams, which in turn means there is shared context, smaller scale that you're working with, and less complexity. All of these things come together, and again, your company, you're trying to, make your point in the market, and you're trying to get features out, and you're trying to do that reliably. But the trade-offs are going to go perhaps on let's get a metric system that works, but you might again make some trade-offs that will bite you in the future. So what are some of those trade-offs? Well, first, let's talk about how we configure alerts. One decision that we had already made is alerts as code. Now, we'll talk about this, or I'll talk about this more in detail, why alerts as code, why dashboards as code. But what this means is the alert is checked into Git with source control, and then it is propagated to the alerting system. This is, for example, what an alert looks like. Now, again, you probably have seen an alert. If you haven't, alert will have a name, will have a condition that you're evaluating over every, like I said, every minute. Perhaps a condition of how long should this be firing until you get a notification for it. Information such as runbooks, target, who should really get notified for this, maybe some metadata. And of course, the level, how should these alert be handled? Maybe in this case, a ticket alert, it could be a pager, and so on. Now notice again in this very complicated condition that I have put in there, there is a deployment variable. And in particular, we were doing something interesting, let's say. Perhaps, a few years ago, we looked at really what do we want when we fire alerts? What is the dimension at which we need to know of a separate notification? And we replicate our infrastructure in clusters and deployments. So really, for most alerts, you want a separate notification for each separate deployment. So if different deployments are having the same issue, you actually want separate notifications. And for that matter, if you get a notification, you want to know what deployment is it for. That meant, at the moment, we just replicated all our alerts by every deployment. So you define your alert definition, such as here, and then you say what deployments are you going to import this alert to, if you will, or what clusters. Then we copy that alert over by however many deployments or clusters there are, and voila, you've got your separate notifications. That works, at a relatively small number of alerts. But what you get after some time is 100,000 alerts. And I can tell you that was pushing the limits. Now, it's 100,000 alerts, but only 1,600 unique alerts, if you will. So we really only needed 1,600. We were pushing the limits ourselves. This is to say there's complexity and there's scaling limitations. It's not all due to just inherent limitations with a metrics system or the backend we were using. It's also decisions that you make yourself early on. So another consideration, and then which we saw here and we'll revisit, configured in YAML. We'll talk more about that in a moment. So what do we move to? First, Prometheus-based monitoring. And this, in particular, let me talk more generally about why Prometheus-based, and we can talk about more specifics. Now, again, this talk is not so much about all the details of the system that we chose and why we chose it and so on. It's about how we migrated, given that we chose, again, a Prometheus-compatible system or Prometheus-compatible API. But I want to talk about why we did that. So the first is open source. We like open source, first of all, because we learned our lesson. Being in a blocked environment and getting to the point where you reach a lot of limitations and when cost becomes a big pressure, well, the way to get out of it is rewrite your alerts and dashboards and do a very fundamental change in your infrastructure. That is an expensive investment. Just to give you an idea, again, this talk is titled How We Migrated in 3 months. Obviously, we didn't implement everything in 3 months. What we did, though, is the entire company, over a 3-month period, migrated their dashboards and alerts to this new alternative. So we know what we know right now, but we know that in the future, we might reach to some new limitations. We might need to make changes in the system that we're using. So an open standard is a good thing. For that matter, also an industry standard. The Prometheus is used across the board. There's many metric systems that have Prometheus-compatible APIs, and that is reassuring. There's clearly a lot of push and competition out there, people trying to build more scalable and efficient and reliable metric systems, and we want to ride that. And we want to know that, as things progress, there will continue to be alternatives. There will continue to be options, and for that matter, there are resources that we can use today and that we could use for the migration to be successful. And flexibility. In particular, again, we have the Prometheus compatible APIs. And we'll talk more, I'll show you more a diagram in a moment. But you've got, on one hand, the metrics backend, then you've got the visualization layer, dashboards, then you've got the alerting system, and all of these things. They could be a package, they could be separate, but you can plug and play and you can mix and match. And this is important. You might choose right now to use a particular vendor that's Prometheus compatible, but later on, perhaps it makes sense to have your own alerting layer and you just replace it. You can do that. You're working with this open, again, standard. And so you maintain that flexibility going into the future. I want to call out, bringing up, in this case, this new system still had challenges. We had to be working closely with Grafana, who is who we partnered with for this. Again, we host the infrastructure. But we were able, and at the moment, we are running actually much bigger than our previous scale. We're growing closer to 100% year over year for various reasons. And we're working well, obviously still looking at always how to continue to scale up and be successful. And we continue to use an allow list and to iterate on how we do the allow list to continue to protect our system and, again, give ourselves the tools to be reliable. So, why dashboards and alerts as code? First, and maybe let me talk a little bit about what it is before, right? I already showed you we were already using alerts as code to some extent, and dashboards, we were just using the in-UI solution of our previous vendor. Everyone has their own version of this. You go into UI, you play with the editor, you build a dashboard, you got it. So why alerts? Why dashboards and alerts as code? First, audit trail. And again, we're talking about dashboards and alerts here, and by extension, we're talking about the reliability of your system and of your company. There will be incidents. There will be postmortems. And sometimes the postmortem will include, well, the alerting didn't work, or you didn't get an alert, or maybe you got an alert, but it just took too long to resolve this incident. You took a long time to find the right answers or find out what was going wrong, find the right signals. And as you're doing that, maybe you realize in your post-mortem, well, we should have had a dashboard, or maybe we had a dashboard and there were some changes and they broke the dashboard, or so on and so forth. We had a lot of that with dashboards before, where we thought we had a dashboard and then it was broken, or people copied dashboards multiple times. It wasn't clear what was the right one to use, and so on and so forth. An audit trail will help you out. Quality. Well, when you have resources as code, in this case, alerts and dashboards as code, you're chunking them into Git, you're putting them through a code review process. So just like you do for your code, in this case, it is good to have someone, a peer reviewer, to have another pair of eyes on those changes. This ensures that, first of all, you are more likely to be doing the right thing, and again, enforcing best practices, standards, etc. Relatedly, then common libraries. Now, this isn't exclusive to as code per se, but you definitely have more degree of control over it. You're able to provide your own libraries or work with external libraries for how to build dashboards and alerts, again, following best practices, and then solving common problems that different teams might tackle in different ways. So, I'll show you an example now about this. Let me just talk about what we moved to. In particular, Jsonnet. Now, Jsonnet is this, and I'll walk through this about what this means. But it is a configuration generation language, open source, and in particular, it is a language that is powerful. It is Turing complete, but it is geared for this kind of use case. It is a superset of JSON, and there are common libraries already that allow you to do this migration even faster. So for example, there's Grafana, a dashboards as code library that integrates neatly with Grafana, one of the more common visualization tools out there. And then you're able to just build your own libraries on top of that, provide your own interfaces, and off you go. What is this dashboard, for example? First, we import some of our internal libraries for the most basic components, a chart, a dashboard, a section. Now, another aspect I haven't touched on yet is the team that we have here. Another problem that we had previously is the lack of attribution or the lack of ownership. You have a dashboard sitting out there, you don't really know who it belongs to. You've got an alert, and sometimes with alerts, you also don't know who it belongs to. This is especially relevant, or this was actually a problem, when we were trying to migrate, because you're trying to ask teams to migrate their dashboards and alerts, and all of a sudden you realize there are plenty of dashboards out there that people are using, but no one claims to own it. Now they use it on a daily basis, but they didn't build it, so they don't own it. So we solved that. Let's have a clear definition of what is a team. Let's map that to some internal definition of that team, and let's have every dashboard, have that by default. You define a query, and similarly here, you can leverage libraries. This is relatively simple, so we don't see that here. But you can have complex libraries to build, in this case, PromQL, which we'll talk more about, and other common patterns that are used. This is especially helpful in a big migration. You define again the chart, as I said here, section, the chart goes in there, and then the dashboard. So let's talk about updating the alerting framework. Now I've already touched on these things, but just to summarize, the second point, YAML to Jsonnet, we get the additional power and flexibility. But then deployment-based, obviously we fixed this mistake. Big migration, I think this has been an implicit maybe point, but to make it clear, it is an opportunity to stand back and reevaluate what would you do differently. And we did that, so this is one of the most obvious use cases. Now in Prometheus and in Prometheus-based systems, by default, you do get a different alert for each unique combination of labels. So we leverage that, and then we build some tooling on top of it to help teams that still need perhaps notifications centered around deployments. So this is a quick overview of some of what I've been talking about, high level, but just to make sure it's clear. You have the configuration files. I say file, but you've got dashboard config, alert config, team config. This go into Git. Then you've got a system that sends that over to the alerting system or to the dashboard system or visualization tool. And those read from the backend, in this case, Prometheus-based metrics backend. Obviously, your UI is the visualization system, which you can also use to visualize alerts. And the alerting system is what will be sending the notifications to, whatever pager tool you use, or ticket, etc. So now let's talk more specifically about adapting to this Prometheus-based API. In particular, note that Prometheus has its own query language, PromQL. Now, this is another big consideration or a big risk that we were looking at. We're saying, well, we need to migrate. We need to move over to Prometheus-based system and then PromQL, and we need to engage teams to migrate their dashboards and alerts. We can't just copy them over. There's not really a one-to-one mapping between different languages, or it's not deterministic at least. And frankly, there's a lot of lost context. There's some things that weren't even doing what they were supposed to be doing. So this was an opportunity to get it right and to not make it worse. So that said, there's that risk, because you're asking teams who have a bunch of dashboards and alerts. Many of them, they don't really have context over. Many of these were written years ago. The engineers that wrote them left. Systems that maybe even lost ownership, or they're not as important anymore. So you're asking them, hey, look at this dashboard and this alert and this query that someone in your team wrote how many years ago, and convert it to this query language, which is new to you. You're only learning now. And this is also a very critical part of our monitoring infrastructure. If you get it wrong, you're going to miss your alerts and your system will be down. So it's a little dire, and you want to get that right. Let's look at, again, what an alert looks like, and then we'll visit what are the options to solve that problem. Again, alerts as code, similar to a dashboard. You've got your libraries and team that you plug in. Here, again, libraries for building things like your PromQL will be helpful, and especially to create common patterns about how to query for common alerting scenarios. You've got the usual fields, name, expression, etc., level, description, team. So, again, before, after, And yeah, again, big migration. We are going to be asking all teams, get over to this new fancy system and do it right. And if you don't do it right, your system might be broken and you won't realize. How do we get that right? Really, there's two options, and what you need to be doing is validating your assumptions. First is backtesting. Now, to some extent, you have this available in most metrics interfaces. You're able to plot your expression. You're able to see when it would have fired. Some have a fancier option for this than others. But you're able to see, well, I expected the alert to fire here and it didn't, or I knew that I had an incident and I should see this here. This is common if you're actually editing an alert after you realize it, for example, missed an incident. But this is not enough. If you're just doing backtesting, obviously you don't have any recent metrics. You don't have that history. This is a big migration too, so people are, to some extent, also changing how their metrics worked. And additionally, you have to bear in mind, this is not great for edge cases. So you don't want to just run into an incident and realize like, there was that edge case, I didn't think about it, let me fix my alert. That's a little too late. I mean, you should if you got to that point, but it's not enough. But there's unit testing. So alerts are important, as I keep saying. And you unit test your code. You want your code to be right. You look at the most granular units of your code, at the functions, and you think it's doing something, and you validate all of your cases, and you write unit tests for it, and you plug those unit tests into your release workflow, and so on and so forth. Alerts should be looked at the same way. So, another advantage of the standard that we moved to on the Prometheus-based system, there is a tool to unit test your alerts, Prom tool. Now in this case, we're looking at a base alert unit test file. This is from the Prometheus standard, so this is the raw unit test file that Prom tool in this case takes in. But to explain what it is, and I'll show how we actually use it, you define your input series. This is mock data. So you're just setting, essentially, think of it as your own local snapshot of what a metric system would look like, all the data that it would have, and the alerts that are running on that system. So you can add as many series as you want, with as many label combinations as you want, define what the values look like over time, and then you add your test cases over it. This is just one test case, but again, you set here your evaluation time at 21 minutes, what alert you're targeting, and then if you expect it to not be firing, then you just say that. If you expect it to be firing, what labels is it expected to be firing with? Remember, I haven't pointed this out super clearly, but the labels themselves are an output of your aggregation and more generally your query or your alert expression. So they're important to validate that you got the alert that you actually expected. And this, obviously, you expand it to then all the possible edge cases that you're considering. These are code reviewed, so you've got your peers helping validate that you thought about things correctly. And there you go. Now this is a raw config. And this gets to another advantage of why we chose to have our own interface, in this case built in Jsonnet, for building alerts and dashboards. For a big enough company, at some point, you really don't want your users just plugging in raw configs into the system itself. Sending the regular YAML that Prometheus or Prometheus-based systems might expect for alerts, you're going to run into conflicts, things might break, validation might be hard, parsing might be hard, so on and so forth. So you have your own layer on top of it. And then we need to build our layer for unit tests on top of it as well. It's like this. It's not that complicated. So similar, we have our unit alert testing library. And you define your samples on it, and then you find your test cases, similar to what we saw before. Then, how do you run this? Well, you just run it. We have a tool called Ollie. It's our internal Swiss Army knife tool, if you will. So you're locally building your dashboards and alerts and relevant configuration. And then you can just test any file on demand or any teams or so on. And importantly, this is integrated with the alert release workflow. So when there are merge gates in place, when you're making changes to alerts, unit tests, etc., that run all of these by default. So in this case, during the migration, teams knew, one, when they're adding alerts, they're doing what they think they're doing, and when they merged, they're still doing what they think they're doing. And of course, as you go on, you change things. You change the libraries that are behind, a lot of these alerts are used across them, and sometimes across alerts and dashboards. You still validate that after these changes, which might be cross-cutting, you have your alerts continue, your tests continue to pass. So, in summary, what did we do? Well, 1,200 unique alerts were migrated. We started with 1,600. We realized a lot of these alerts were actually not necessary anymore. So we ended up with 1,200, all successfully migrated. 200 dashboards as well. And finally, unit tests are used across the board and help to validate the migration that the teams were doing. The effort was successful in the end. We were able to accomplish all 70 plus teams that migrated their alerts and dashboards. And usage, after that, we had some time to still have the previous system available as a backup in case things went wrong. Ultimately, it was fine. That is now deprecated, and we're living in this new Prometheus-based world. And we're seeing, again, now we're looking at new problems. We find that when you build cool things, people use them more. So as I mentioned, we were at 60% year over year metric ingestion rate. Now we're at over 100%. So new problems, new things to work on. Now we're looking at how we make our allow list better, how we help narrow down what metrics are really necessary and so on, how we have a long-term vision for scaling up the system. But it's a better place to be. Thank you very much.